Download this code from codegive.com, link in the description below. Certainly. The echelon form, or row echelon form, of a matrix is a form used in linear algebra that simplifies the process of solving systems of linear equations. A matrix is in row echelon form if it satisfies the following conditions. 1. All non-zero rows are above any rows of all zeros. 2. The leading entry, also called the pivot, of each non-zero row is 1 and is to the right of the leading entry of the previous row. 3. The leading entries, the pivots, in each row must be strictly to the right of the leading entry in the previous row. In this tutorial, we will demonstrate how to convert a matrix to its echelon form using numpy in Python. Step-by-step guide. 1. Import libraries. We will use numpy for matrix operations. 2. Define the matrix. We will create a matrix that we want to convert to echelon form. 3. Implement Gaussian elimination. We will write a function to perform the operations needed to achieve echelon form. 4. Display the result. Finally, we will print the resulting echelon form of the matrix. Code example. Here's how you can implement the above steps in Python using numpy. Explanation of the code. 1. Importing numpy. We import numpy as np, which allows us to use its array functionalities. 2. Function definition. The function row_echelon_form takes a matrix A as input. 3. Finding pivots. We iterate over each row to find the pivot. If the pivot is 0, we look for a row below it to swap and make it non-zero. 4. Making the pivot 1, we normalize the pivot row by dividing the entire row by the pivot value. 5. Elimination. For every row below the pivot, we subtract an appropriate multiple of the pivot row to eliminate the values below the pivot. 6. Result display. We print the original matrix and the resulting echelon form. Conclusion. This code effectively transforms a matrix into its row echelon form using Gaussian elimination. You can modify the input matrix A to test with different systems of linear equations. This method provides a clear example of how to handle matrices in Python using numpy, making it useful for various applications in data science and engineering.